Hello and welcome to Khaliltronics. In today's video we are in another topic called limit. So in this new topic we are going to see how limits itself. So basically there is many and better way to find the value of the limit than graphical or flogging and the number to get closer and closer to find the value interested. So actually this solution method fall under three categories: that's substitution, factorization, factoring, and then conjugate methods. But first thing, let's discuss with some of the general rules for the limit. So we have the first one, which is sum rules, and then we have the difference rule, product rule. So let's start with the sum rule. So if you have a limit x approaches to infinity, if you have limit x approaches to c of f of x g of x, so this will works into limit x approaches to c, that's x approaches to c of f of x. So you have to take it individually, limit of this f of x plus limit of this g of x. So and then this x approaches to infinity, meaning that to substitute x as c in the function of g. Likewise for the difference rule, is just the negative sign, so it just breaks. You take the limit of x approaches to c for the first one, and then limit x approaches to infinity for the second one, that's g of x. So you just take it individually, and then this is for difference, this is just negative sign, and then this is limit x approaches to c of g of x. So like for the product rule, if you have limits, like if you have limits, limit x approaches to c of f of x times g of x, so it's just take it individually. You can say limit for the first one multiply by the limits, that's limit of this f of x, multiply, that's multiplication between them, multiply with another limit x approaches to infinity of g of x. So if you have something like this, it's just multiplication between them, so just need to distribute. So likewise for the constant multiplier, that's constant multiple, you just, if you have limits x approaches to k c, I mean that's k multiplied by f of x, you just make it to be the coefficient, and then limit x approaches to c of f of x. Likewise for quotient rule, is just division, so you take a limit of the numerator divided by the limit of the denominator, as you see right here. So we are going to take some many example and see how it is work. So let's take question 1 and see. So question number 1 is example 1. Example 1, let's change the pen. Example 1 is we have limit x approaches to c of x square plus 4 x square, here is x cube, and then minus 3. So to get this, we have to get limit x approaches to c, x cube plus 4x minus. So here is a combination of substitute difference and then sum rules, and then the product rule, that's constant multiple. So what you need to do here, you have x approaches to c, so wherever you see x, you just need to replace c instead of x. So we can say limit x approaches to what c of what x cube, then plus limit x approaches to what c of what 4x square, then minus limit x approaches to c of what 3. So as you see here is constant, so you can shift it back. We can see limit x approaches to what c of what x cube plus, since here is the constant, so you can put it back, then limit x approaches to what c of what x square, then minus what limit x approaches to what c of what 3. So from here we can just substitute wherever you see x, we put what c. So x cube, x approaches to infinity to c of x cube, so we can say c replace x, then you have c cube plus, here we have 4 as coefficient, remain same, then limit x approaches to c of x square, then we have what c square, then for the last term we have limit x approaches to c of 3, then we have what 3. Here if you like you can see to become here, and then here we don't have anyone, you have what 1 as multiple is saying, here it become just 1. So we have here c cube plus what plus 4 c square minus what 3. So here this is the answer. So let's take another questions and see. So another question we have is example 2. We have limit x approaches towards c of what x raised to power 4 plus x square minus 1 all over x square plus what 5. So what you need to do is to just take this is quotient rule. You just take limit x approaches to infinity of this, the whole this, and then limit approaches to infinity for the denominator. So we can say limit x approaches to what c of what x power 4 plus what x square minus 1 all over what limit x approaches to what c of what x square plus 5. So also you can distribute the limit, since here is like this, also here is like this, so you can distribute it. You can say limit x approaches to c of what x power 4 plus what limit x approaches to c of what x square minus limit x approaches to what c of what minus 1, and then for the denominator we have what limit x approaches to c of what x square plus what limit x approaches to what c of what 5. So for the numerator we have x approaches to c, so we can substitute what any place we see x, we substitute. So we have what c for what 4 plus what c square. If you substitute c to here, we have what c square, then minus limit if you substitute here is just what 1. So for the numerator we have, we substitute c to be equal to x, then we have what c square plus what here to be 5. So the answer is just like this, c square c raised to power 4 plus what c square minus 1 all over what c square plus 5. So So this is the final answer. So let's take another question and see. So another question is like we have limit x approaches to 1. So here is our numerical one. So of x raised power of what 4 plus what x square minus 1 all over what x square plus 5. So what you need to do, any place you see x, just replace it at 1. But first you have to distribute it, since it's just like quotient. We can say limit x approaches to 1 of what all this, that's x power 4 plus what x square minus 1, and then for the denominator you have what limit x approaches to 1 of what x square plus what 5. So similarly, it's just substitution. This one you can distribute this one and say limit of the first one, limit of the second one, limit of the third one. So no need to do here, we don't want to waste time. You can say limit of this, limit of this or other one. So here we can just substitute for the x square at x raised power 4, we can see 1 raised power 4, then plus what for the square we can see 1 square, and then we have what -1, and then for this denominator you have 1, we have 1 square plus what 5. So we have 1 plus 1 minus 1, we have 1 all over 1 plus what 5, which is equal to 1 over 6. So limit x approaches to 1, x power 4, x plus x square minus 1 all over x square plus 5 is equal to what 1 over 6. So let's take another question and see. So another question is given as what example. So it's what limit x approaches to what to 2 of what of what x plus what 2 all over what x square plus 5x plus 6. So it's just substitution. You can say any place you see x equal 2, so you can say firstly you can say limit x approaches to 2 of what numerator, that's x plus 2, and then for the denominator you can say limit x approaches to 2 of whatever in the denominator, that's x squared plus 5x plus 6. So you just substitute. We have what our limit is 2, you can say 2 plus 2 all over what 2 square plus 5 into 2 plus 6. So we have 4 at the what top, and then for the bottom we have 2 square is 4 plus 2 times 5 is 10 plus what 6. We have 4 all over what 10 plus 6 plus 4, which is what 20. So likewise we have what 1 over what 5. So we are going to take, and as this is for the rules, that's for some rules, difference, product, constant, and quotients. So we take those. If you have something like this, let's say example, find the limit x approaches to what 4 of what x squared plus 2x plus what 7. So you can see just substitute x as 4. So you can see we have 4 squared plus what 2 into 4 plus what 7. So we have what 16 plus 2 times 4 is what 8 plus what 7. So whatever the answer will give you the. So this is how it is. So we are finishing with, we have done with the basic limit rules. We're going to start with factorizing also and see how it is work. So factorizing methods. So I think we are going to stop. Let's take another question. So in the next video I will do for factorizing and then conjugate methods. So let's take another questions and solve. So another question is limit x approaches to 2 of what x plus what 3 all over what x plus 6. So h approaches to 2, so you have to just substitute. Likewise, this is what if you like, you can say limit x approaches to what 2 of the what numerator x plus 3, and then all over limit x approaches to 2 of what x plus 6. So you just substitute. We have what 2 plus what 3 all over what, for this one we have 2 plus 6, which is what 5 by 7. So another questions is x approaches to, another question is limit x approaches to what minus 5 of what x square plus 3x minus what 5 all over what x plus 7. So you just substitute x as negative 5. So we can come and say limit for the top and the limit for the bottom. So we just substitute, no need to do like we did for the previous one. So just take limit for the top and then limit for the bottom and then substitute. So we have to just substitute. That's minus 5. Yeah, we have x, we can say square plus what 3 into what negative 5 and then minus 5. Then yeah, we have minus 5 plus what 7. So minus 5 square is 25 plus 3 times negative 5 is what, negative 15. So here we have negative 15 and then minus 5 all over what minus 5 plus 7 is 2. So here we have 25 minus 20, which is 5 by what 2. So here is it. So this is how to do it. If you have something like this, let me have, so if you have limit x approaches to whatever, maybe c or 3 or 4, whatever is given, limit approaches to something, if it's c, so you have to just, let's say of x squared plus 3x, so you have to just substitute c instead of x. So we can come here and see we have c squared plus what 3c. So it's like this. If it is here is 3, we can just say here we have what 3 and then here we have what 3. So if it is 4, likewise for any number. So this is the end of the video. Don't forget to give like, subscribe and comment. Thank you for watching.